Hello everyone. So today let's solve the problem number 130, surrounded regions, right? So let's see what the question states here. We are given an m into n board of x and o. So this one x and o, right? So we have been given an m into n board of x and o. Uh, we have to capture all the regions of o. All we need to do is we have to capture all the regions of o. Yeah. So this one. Yep. O that are fully surrounded by the x. So it has to be fully surrounded by the x man by flipping them into x. First of all, O has to be fully surrounded by x. Then we can just fully this one flip them into the x, right? So again, we are given an m into n board of x and O. We have to capture all the regions of O that are fully surrounded by x by flipping them to the x, right? So regions connected to the board edge remain unchanged, right? Regions connected to the board edge remain unchanged. So all we have to do is modify the board in place and we do not return anything. So this is very important. We have to modify the board in place and do not return anything. Yeah, just keep this in mind. Yeah. So now let's go with the this one approach part. So first thing before getting into the approach part, see here we have been given xxx this one x double o x. So this one this is fine, and this is also fine, and yep xx0 this one ox and xo double x, right? So here this is fine. Here, see, in the above diagram, the bottom region is not captured because it is on the edge of the board, right? Edge of the board, and it cannot be surrounded, right? So this is on the edge of the board and it cannot be surrounded. This is surrounded by X, and this one is surrounded by X, and this one is surrounded by X. So all these three O's can be this one changed into the X or flipped into the X. So this one bottom where I'm pointing to now, this one cannot be captured. See here in that above diagram, the bottom right region is not captured because it is on the edge of the board and cannot be surrounded. They have clearly mentioned. Yeah. So this one. If we have only single element in the grid, then we can just directly this one. What do we call? Output the same thing. Yeah. So this is fine, I believe. Now they have given us wonderful examples just for the sake of understanding, right? So this is one of the fantastic questions, man. Now let's do one thing. Yeah, we will be solving with this one with a DFS, actually with the help of DFS. The previous one we solved with the BFS. So now let's go with the DFS. Yeah. So let's go with the iterative DFS for a change. Yeah. Let's go with the iterative DFS. Yeah. So this is fine, I believe. Now see, let's consider the same first example. Just give me a second here. Let's consider the same first example, this one. Yep, let's consider the same first example for the approach. So the first one here is, let's treat each cell as the node, right? So this one, each cell as the node actually, right? In the grid graph, and let's use the DFS from the border O, from every border O, from every border O to mark all reachable O's as safe, right? So they cannot be captured in the single terms, right? So from the example, we will start the DFS from the edge O at 3, 1, right? So this one, 3, 1. So we are starting with a 0, 0 here. So this goes with the same. So this one will be 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2, 2, 3. Same goes with 3, 0, 3, 1, 3, 2. So this one will be 3, 3. So where we will be starting from actually, this one 3, 1. From the example, we'll start the DFS from the edge. Oh, this one 3, 2. So we'll start from here, right? So this one is 3, 3. Sorry, we'll start from here 3, 1. It marks only 3, 1 safe, right? No other border O's exist here. No other borders O's exist here. See, 3, 0 we have X here. 3, 2 we have X, and 3, 3 also we have X, right? So it marks only 3, 1 safe. No other border zeros exist here. After marking safe, zeros temporary mark S. So this one will traverse the board, right? So we'll convert the remaining zero, this one zero surrounded ones to the X. We'll convert this one remaining zero surrounded ones to the X, and we will convert S back to O. We'll convert X back to O, right? So result, what will be the result, right? all the interiors O that were not reachable from the border or flip to X. This one that were not reachable from the border, basically these three things. Yeah. So this one. So this is actually 1 comma 1 and 1 comma 2. So this one will be flipped X actually here. See this part 1 comma 1 and 1 comma 2. So this one will be 2 comma 2 actually, right? So this 2 comma 2 will be flipped to X as well, right? So basically all the interior O's that were not reachable from the border or flipped to X, border connected to O. This one, this is the only border that is connected to the this one. What do we call? Oh, actually this stays and we cannot flip this one. This remains same actually. Yeah. So the output that we get here is this one actually. X 4x, this one actually. Double X double X, X X X X again. So this one 4 times X again. The final one will be XO double X. Yeah. So this is fine. So the output that we got here matches the output that they have given for the example one. So our approach works absolutely correct here, right? So this is how we will be making use of the DFS. Start from here, then the interior ones actually, which is O actually, and which are not at the border O. That one we will be flipping to the X. Then finally, the one that is connected to the O stays here. In this case, it cannot be flipped to the X. This remains, and all other this one cells at the interior ones or the interior ones, basically it will be flipped to X. So this one will return this one as the output, simple one. So we'll be performing DFS from the border one, the bottom, this one, bottom cell actually, 2 comma. So this one will be 2, 3, 3 comma 1 actually. We'll be starting the DFS from here. So this is the idea basically. Yep. So I hope we got this one. Yeah. Now let's do one thing. As we are completely familiar with the approach part, let's do one thing. Let's quickly discuss the complexities part. Yeah. So what will be the time complexity here? The time complexity would lead to big of m into n. The time complexity would lead to big of m into n. What would be the space complexity here? The space complexity would lead to big of m into n as well. So the time complexity would lead to big of m into n because every cell is visited at a constant number of times. Yeah. Uh, Basically, we'll be going with a border push as well as the DFS marking. After visiting the cell, we'll be marking that one as visited, right? Border push, DFS marking along with the final pass. Yeah. So overall time complexity would quite obviously lead to big of m into n. So what will be the space complexity here? The space complexity of would lead to big of m into n in the worst case because as I've said, we will be going with a iterative DFS. Yeah, I mentioned this one earlier, right? So we will be going with the iterative DFS. So iterative DFS uses stack quite obviously. Yeah. So now the stack may hold up to every cell, right? Meaning, so it can be all O's, right? So here it can be all O's. So I cannot draw to the this one. So let me do this one instead. Yeah. This one basically what stack may hold up to every cell, right? Example, all the O's actually, right? In the worst case. So overall space complexity would lead to big of m into n as well, right? So overall space complexity would lead to big of m into n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of m into n respectively. Now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. First, as usual, let's handle the trivial board or null case. Yeah, if the input is null, we have nothing to do, right? So we have to exit from there. So I'll just go with if board equals null, then let me give return here. So this is fine. So let's consider the number of rows next. I'll just go with the variable m. So this one will be board dot length. Yep. Next, let me go with a case here. If the empty board, then we have again nothing to do. This is related to the this one when m is equals to 0. So when m equals 0, we have nothing to do. So we have to exit. So let me give return here, right? So let's consider the number of columns now. So this one n equals. So let me copy here. Let me paste it over here. Length of the. So this is fine. Next, if the empty board, again nothing to do. This is related to the columns instead of the rows. So here this will be if n equals 0, then to exit or to terminate, so we'll make use of the return keyboard. Now let's do one thing. We'll perform graph traversal nothing but the DFS from all the borders O's and mark them as safe with the S, right? So let's make use an iterative stack to avoid the deprecation issues. So that is the reason I'm going with the basically iterative DFS. Yeah. So one more thing is we use BFS quite often. I use BFS quite often when it comes to graph. Actually, I wouldn't lie. So I love using the BFS when it comes to graph-based questions, and I love using the recursion when it comes to trees actually. Yeah. So code will be lesser. BFS because most of the times you'll get out of that particular headache, MLE issues, right? And the optimization. So it's better to go with the this one BFS. Most of the times I use the BFS in the graph due to the this one fear of getting MLE basically, right? So that's one reason. Even though a bit this one, what do we call? Uh, Iterative DFS or the BFS. Most of the times, I use the BFS part actually to get out of the this one uh, MLE issues, and further optimization is not required. Most of the times when you go with the BFS directly, along with any data structures actually, right? So most of you'll avoid basically you it will be easier to avoid the ML issues, basically in simple terms. Yeah. So, yep. Now let's do one thing. For this, we are making use of the iterative DFS and we'll perform the graph traversal DFS from all border zeros and mark them as safe with S. And then we'll be making use of the iterative stack to avoid the deprecation issues. Yeah. So I'll just go with DQ. Let me go with the integer here. So let's do one thing. So this one will be stack equals. So let me go with array DQ. Let me pass the integer. Let me pass the integer. Right. So this is fine. And let me make this one capital I, or else we'll get the error. Yep. So this is fine. So the next part would be let's push all the border O's onto the stack and mark them immediately as S. Right. So for this, let's go with the for loops everywhere. So this is fine. 0, j less than n. Let me increment the j. Yep. Top and bottom rows we are considering, right? So let's go with a simple if condition here. Top row border and then marking safe and then encode and push these three methods. Yeah. Three things actually. First, if condition, we are considering top row border here. So this one will be board of 0j. So this is fine. If it is equal to O actually, then what we will do, we have to mark that one as safe actually. Let me consider board of 0j. This one equals, let me go with the S here. And then finally what we need to do, we have to encode and push, meaning to the stack, right? So I'll just make use of stack dot push here. So 0 into n. So this one has to be 0 into n plus j. This is fine. I'll just get out of this. I'll just come out of this one. Let's write the simple if condition. If m is greater than 1 and let me go with a board of m minus 1 into j. If it is equivalent to the 0, sorry, not 0 actually. Oh, yep. We have to write this one within the strings, right? Yep. Then again, we have to mark this one as safe and encode and push. Same method. So here, let me copy this one. Instead of the 0j, it will be m minus 1j. So this one is same. The same thing. Let me copy here and let me paste it over here. So this one will be instead of 0 into n, let me go with the m minus 1 here. M minus 1 into n to n plus j. Yep, so this is fine, man. We have just encoded and pushed successfully. Now, so let me come out of this one entirely. Let me format this once before we move on with the further things. Yeah. Now, let's do one thing. We are left with left and right columns, right? So, let's skip corners now. So let's go with the left and right column. So I'll just go with one more for loop here for I equals 1, I less than m minus 1. So this is fine. Let me go with the I plus plus. So this is fine for loop. So let's go with the left column border. Let's mark this one as safe. And finally, let's go with the encode and pushman. So let me go with the if here. Sorry. So I'll just go copy this one board actually. If board of I0, so this one, if it is equal to O actually, then what we'll do, board of I as well as the 0. Let me mark this one as safe again. And finally, we have to encode and push here as well. So this one will be stack dot push of I into n plus this time 0. Yeah. Now let me come out of this one entirely. Let me write this one actually. Let me copy this one from here to here. Let me paste this one and make the necessary changes here. If instead of m greater than 1, this will be n greater than 1. And so instead of board of m minus 1, so this one will be 1. Sorry, we have to consider I here, right? So this is fine. I into n minus 1. So we are just going with the right column border here. Don't get confused. So this one, if it is equivalent to the O, board of uh, same thing. Yeah, I into n minus 1 we have to consider, right? I into n minus 1. We have to mark this one as safe. Finally, what we need to push? I into n plus n minus 1. I into, so let me remove this one. I into n plus. So this one will be n plus. Sorry. So this one has to be n minus 1. Yep. So this is fine, I believe. We are just encoding and pushing. So this is fine. Let me come out of this one entirely. Now, let's consider the directions up, down, left, and right. So this one will be int dr equals new int. So this one will be minus 1, 1, 0, comma 0. Yeah. So row deltas. And let's go with the column deltas as well. So this one will be int dc equals new int of. So this one will be column deltas, quite obviously column deltas. So this one will be 0, 0, minus 1 as well as the minus 1. If we are going with a 2D actually, 2D grid, then we have to combine these two, right? So this is fine, man. Not dealing with 2D. So this is fine. For now, uh, let's go with the iterative DFS. Let's mark all the O's reachable from any border, nothing but O as S, nothing but the safe, right? So we are going with the iterative DFS. So let's do one thing. Let's make use of the stack here, right? Standardize DFS, iterative DFS loop actually. Yep. Let's go with file of not of stack dot is empty. So this is fine. Yep. So within the while loop, let's pop the encoded position. So this one will be encode equals stack dot pop. Yeah, stack dot pop. So this is fine. The next part would be let's decode the row as well as let's decode the column. For decoding the row, so this one will be R equals code by n. Yep. So let's decode the column as well. To decode the column, I'll just go with int c equals code this one modulo and yep, this is also fine. Now let's explore the four neighbors man. Simple for loop here. So int, so let's consider k, your variable k. K, we are starting from 0, so k less than 4. So this will be k plus this. Yep, very simple. Now within the for loop, so let's consider the neighbor row as well as the neighbor column as usual, nr and nc. So nr equals here r plus dr of k. This is fine. And also let's go with the neighboring column, nothing but nc equals c plus dc of k actually. This is fine. Yep. Now let's do one thing. let's check the bounds and whether neighbor is an unmarked O or not, right? So first let's go with a bound check. Then at the end we can just check whether neighbor is an unmarked O, right? So first bound check nr greater than or equal to 0. It shouldn't be. And nr less than, so it shouldn't be. And nc, nothing but the neighboring column, greater than or equal to 0. It shouldn't be. And nc, uh, nc less than n actually. It shouldn't be. These are the boundary checks. And final one is we have to check whether neighbor is an unmarked row or not. So meaning here, I can just write it in this way. Board of nr, nothing but the neighboring row, and also nc, nothing but the neighboring column, if it is equivalent to, right? So this one. Yep. If it is, then what we have to do, we have to mark the neighbor safe, right? So I'll just copy the same thing here. Board of neighboring row, neighboring column. So this one, let me set this one to the safe, nothing but S actually here. So finally, what we need to do, we have to push the encoded neighbor to the stack, right? So we are making use of the stack itself. Stack dot push of nr into this one n plus neighboring column. Also, we have to include nc. Let me come out of this one entirely now. So we are left with the final step, nothing but final pass. We have to go with the final pass if you remember the approach, right? So we have to flip the captured O to the X. And finally, we have to revert safe S back to the O, right? So let's go with the two loops here. This one int I equals 0, I less than m, I plus plus. Same goes with the column for int j equals 0, j less than n, and j plus plus. Yeah, so this is fine. Now we have successfully iterated over all rows and all columns. So an O not reachable from the this one. What do we call an O? What is this one? What we need to do? I forgot. So just give me a second here. So accordingly with what we discussed, actually, we have to capture an O that is not reachable from the border, right? For that, let's write the if condition. Let's see whether this works or not. So I'll just go with a board of I, j, actually, if it is equivalent to the O, uh, then, so let me set the board of I and j to the, this one, X actually. Yeah, to the X. This is fine, man. Yep. Next, let's do one thing. I'll just go with else if here. Else if, uh, board of I, j, this one equals S. This is fine. Let's we have to restore the original, meaning, so I'll just set the board of ij to the O actually. So board of ij, where I have written, so let me copy this one. Board of ij equals O. Let me copy this one entirely. Yeah, board of ij, we are just restoring the origin. We just have to restore the original actually. Yep. We have successfully restored this one, original one. Yep. So this is fine. Let me format the code one. So this is it for the code actually. Let me give semicolon here. This is not getting formatted. Damn, bro. This is fine, man. Yeah. Anyways, let me run the code. This has to work. Let's see. Hmm, error not a statement. DQ integer stack. What happened here? Line number 9. First, let's check the line number 9 actually. DQ. What's wrong here? So we are going with a DQ, no doubt. 1 second. DQ of integer we are passing, so this is fine. Stack equals new array DQ of integer. Oh, I haven't given new here. I'm just saying with the mouth actually. This is fine. Now one error has to be gone. Have the compile error, line number 58 actually. What's wrong here? Last line, else if we are checking board of ij equals safe. Then we are going with a board of I. Oh yeah, I'm making it with a comparison operator here instead of assigning this one to the. Okay, fine. Now this has to work. We shouldn't be using the comparison operator here, man. We just have to assign this one to the right. So this is fine. New array. Oh, this one has to be capital D. Where it is? Line number 9. The same line. Yeah. So let me change this one to the capital D. Now this has to work. I believe now this has to work at any cost. Let's see. Yeah. Format the code now. Yeah. Now this got formatted actually. Yep. So let me hit the submit button now. Wrong answer. Okay. This test case is failing. Let's check what is expected here. For output that we are getting here is this one. Okay. This is fine. Double X. Oh, so this is also fine. This also we are getting correct. So double. Oh, yep. This is also fine. OX. O double O. OX. Oh, this one. Here we have to get O, but so this is at the center, right? Mm, okay, this is the only thing that we are getting wrong, right? So let's check what we have done wrong actually. So maybe what I have done here, so looking at this, I can just guess I have done something wrong with the this one. Row deltas or the column deltas actually. We have assigned 0, 0, minus 1 something, right? Yes, 1, 1. This is fine. 0, 0, minus 1. Yeah, I have assigned -1, -1 twice. So this has to be actually -1, 1. Yeah. Now let me submit this one directly. So now everything should work correctly. Let's see. In my opinion, yeah, you can clearly see here all the test cases are getting passed, right? So that was the wrong thing. So I have assigned a wrong here. Basically -1, 2 for this one here. This is fine. Now the sample test cases, I mean all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities part. For now, this is it. Thanks for watching, guys.